Hello everyone, welcome to Turito's live class. So in today's class, we are going to understand one of the most important concepts in chemistry. Like my previous classes, I am not going to tell you or reveal you the name of the chapter. Here I would like some assistance from you. What if I am asking you, tell me the things which you all are surrounded by right now in your room. So what those things will be? Yes, you can type in the chat box. Yeah, so I can see it can be a chair, right? You must be sitting on the couch or bed, or there are some table, right? Even you are writing on your notebook. So these are all some or few things which you all are surrounded by. I use the word things, or we can refer these all things as substances. What are we calling them as? Substances. But you know what, in chemistry or in science for that matter, so substances are also known as matter. Okay, this is the specific word which is given in science for all these things which we are all surrounded by. So did you guys get the hint, like what today's session will look like, or it is based on what? Absolutely right. Today's session is going to talk, in today's session we are going to talk about matter in our surroundings. You got it very correctly. So let's understand what are those topics which we are going to cover today. Let's have a look. First of all, we are going to cover what is the definition of matter. How are we supposed to define a matter? Followed by composition of matter. What matter is made up of. Third is classification of matter. So there are so many examples of substances which we all are surrounded by. And if one needs to learn about matter, it's very convenient if we are going to classify matter in categories. And what those categories are, we are going to cover in the classification of matter in detail. Next topic is characteristics of particles. Now, after knowing the physical nature of matter, we are going to talk about something called as features or properties of particles of matter. Now, what are those properties? We are going to cover in here. Then we are having fifth topic for today, that is nothing but physical classification of matter. So, what it comprises of, soon we are going to understand. So, are you all ready for the class? So, grab your pen, notebook and let's get started. So, since ancient time or when people were very curious to know about the science, so from that time onwards, like every human beings are they have been trying to understand about the surroundings, what it is made up of, or what's the chemical constituent of it. Okay, so philosophers, scientists, so they made a conclusion out of that. Matter classified in the form of 5 basic elements. Our surroundings, which is nothing but matter, it is classified in the 5 basic elements which are also known as Panch Tattva. Panch, that means 5, Tattva is truth or aspects of life. What are those? Can anyone tell me? Have you heard about Pancha Tattva? Yes, if you know the answer, you can keep typing in your chat box. And those who don't know, let's have a look. First is air. Second is earth. Third, fire. Fourth is sky. And the last one is water. So these are the aspects of life or Panchatantra. on like when these get combined, we get surrounding, we get matter. Okay, so this was brief history about matter. Now we need to understand what like on what basis are we supposed to define matter. Okay, how I can call a thing as a matter scientifically. So here we go for a definition. Anything which possesses mass, which has its own mass and occupy some space, is known as what? Matter. For an instance, I am holding this remote, okay, it has its own mass and it has occupied some space on my palm. Can we call it as matter? Definitely yes. Third parameter is that something which we can perceive through our senses is called as what? Matter. Okay, so are you all able to see the color of this remote or the shape of this remote, right? So we can perceive the matter through our senses. So what are those criterias? It has to have what? Mass, then it should occupy its own space, and something which we can perceive through our senses has to be termed as what? Matter. Is the definition clear to you all? Is there any confusion? Okay, based on this definition, would you like to give me some examples, like what is matter? Some examples of matter can be book, pencil, watch, yes, clock, AC, remote, pen. Everything which you all are surrounded by is nothing but matter. Even you and I are nothing but examples of matter. We have our own mass, we occupy some space, and we can see each other, we can perceive each other through our senses, right? So yes, even we are examples of matter. Okay. So yes, these are some examples which we talked about, right? Now moving ahead, let me take you through some more examples of matter, okay, for our better understanding. Okay, so the air which we breathe, and we know that air is nothing but what? It's a mixture. It is a mixture, homogeneous mixture. It is made up of so many gases and water molecules. Okay, so that's how we can say the air which we breathe is nothing but a form of matter or an example of matter. Moving ahead, we are having the food we take. Okay, so image is quite delicious, right? We are having dosa, idli, sambar, etc. So these are nothing but examples of matter, because I can see, like if I am going to weigh some of these, they are going to have their own mass. I can see they have occupied their space, right? And we can perceive them, right? So it's very delicious. Okay, let's move ahead. Now moving ahead, we are having stones as example of matter. Again, the parameters stay same for this also. It is consist of so many chemical constituents, and they are having their own mass, and they can occupy their own space. We can perceive through them by our senses. Moving ahead, clouds. So even clouds are examples of matter. Do you know that? It is comprises of so many chemical ions in it, and that's how we say clouds are nothing but form of matter or example of matter. Even these cows or buffaloes or grass, air. So there are so many examples of matter in this one picture, right? Moving ahead, we are having stars. Even stars are considered as examples of matter. Can anyone tell me how? Yes. Okay. I can see like blank spaces are there. Don't worry. So stars are comprises of gases such as hydrogen, helium, and hydrogen, helium are nothing but what? Elements, gases, and that's how we say clouds are examples of matter. Moving ahead, we are having plants. Okay, so plants are also examples of matter. All living organisms are nothing but examples of matter. After plants, obviously animals, albeit elephant, lion, giraffe, zebra, anyone, you and I. Okay, so we all are examples of matter. Then yes, we are having our life, water. So very small drop of water, such as like if I want to write the chemical constituent of water, H2O, hydrogen and water, it is consist of, right? So yes, it is also example of water. matter. Then moving ahead, we are having what? Sand. Sand is, why do we consider sand as a matter? Because it is consist of a lot many other things along with majorly SiO2, silica oxide is there, okay, and this is nothing but these are different elements which sand is made up of, and that is why we say it is a matter. So now after finishing some good examples of matter, we need to understand like how a matter looks like or what matter is made up of. Like what are those things inside in a matter? Actually there were, like for a long time there were two schools of thought prevailed regarding the nature of matter. There were people, group of people, two different groups of people who were they were having two views about like what the matter is composed of. Some said that, one group of scientists assumed that matter to be continuous, okay, and the other group said that matter was made up of particles. Okay, so matter is made up of particles. So what is this? Do not worry, I am just giving you an example. Consider that you are holding a long sheet of glass, okay. So when we see it, superficially or like exteriorly, what do we observe? The chemical composition or that particular glass sheet is quite continuous, right? It is same throughout its composition. But what if we are going to throw the same sheet on the floor? It is going to break down, and breaking the glass sheet going to give us what? Small particle, because it is comprises of particles. So if I want to say what is the physical nature of matter, it has to be what? Particulate. That means matter, though it looks like continuous, but when we see, it is comprised of many or several small particles, and that is how we say physical nature of matter is particulate. It's very simple, it's originated from particles like particulate. The nature, physical nature of matter is particulate. Okay, is there any confusion? Are you all following till here? Is there any doubt? So we have seen the definition of matter. Then what matter is made up of? It is made up of small particles. All right. If anyone wants to take note out of this, they can quickly. So physical nature of matter, continuous, and matter is made up of particles. Though the continuous, why are we saying? Though it looks like a continuous thing, uniformly distributed, but actually it is comprised of small particles, and that is how we are saying that or concluding that matter is made up of particles. It is particulate in nature. All right. After knowing the chemical composition of matter, it is time to understand that how are we going to study matter. There are so many examples, right? So if one needs to study about matter, we need to classify matter in different categories, okay, and that is how the categories are. First is physical classification, which is based on the physical nature or physical properties of matter, followed by second classification is chemical classification, which is based on the chemical properties of matter. I said two words here. Physical property, right? And second classification, which is based on chemical properties. Now what these properties are? So do not get panic, or it's very easy to understand. Let me put it here. So physical properties like more into, or they talk about the exterior composition of matter, something which we can observe, something which we can measure. or properties which we can observe, properties which we can measure are nothing but physical properties of matter. What are those? If I want to give some examples, I can talk about what color, I can measure the size, right? Even shape, even a physical state, etc. Okay, so based on the physical properties, we have classified matter into physical classification. Okay, and if I want to comment like more specifically, physical classification is majorly based on the states of matter, and what these states of matter we are going to cover soon. Now the second part, like second classification based on chemical properties. Chemical properties are something like interior of the matter or internal structure, or internally how these particles are arranged. Okay, so I can write here. It gives idea about matter internally. Okay, so it can give you information about the arrangement of particles, it can talk about a bond which is there among the various particles. Even it can talk about the chemical reactivity among these atoms. Okay, so or even it can talk about the composition, whether it's pure or it's impure, etc. Okay, so that's how there is like a big difference between physical property and chemical property, and based on this we are having physical classification of matter and chemical classification of matter. Is that clear? Is there any doubt? Okay, quickly make a note of this. Done? Now moving ahead, in this class, as I told you in the objectives, that we are going to learn about the physical classification of matter, which is based on the states of matter, like states such as solids, liquids, gases, plasma, BEC, etc. But before that, I just want you all to get familiar with chemical classification of matter. Now, on the basis of chemical composition, matter is classified as what? Pure substances and yes, impure substances, which are also known as what? Mixtures. Okay, so in the universe we are having two types of matter which are chemically classified: pure substances, and second category is mixtures. Now what do you mean by pure substances? Pure substance, word itself saying that a substance which is consist of same or similar kind of atoms. If I want to give an example, suppose if I am having iron rod, okay, this is a rod which is made up of element iron. So what do you expect? What it is made up of? It is made up of small atoms. All of them are nothing but what? Iron atoms. Okay, these are all iron atoms, and we know iron is an element, it's a metal. So it is example of pure substance. Now here talking about compounds. Compounds are nothing but pure substances, but they have fixed combination ratio. Fixed ratio. They come in fixed ratio, such as if I am taking water samples, like you are bringing water sample from your home, I am bringing water sample from my home. So its chemical formula is going to be the same. 2 parts of hydrogen getting combined with 1 part of oxygen, giving you H2O, which is in the fixed ratio. And these are like hydrogen and oxygen, these are the atoms which are getting combined with each other chemically, and that's how we say compounds. Okay, we refer them as compounds. So it was just a small idea about pure substances. Now talking about mixtures. So mixtures are nothing but where we are having different kinds of atom, we are putting them together. They are not chemically bonded with each other, they are just staying there, they are physically bonded. So they can be homogeneous. Okay, so mixtures can get further classified as homogeneous mixture and heterogeneous mixtures. Okay, if I want to give example, homogeneous mixture, if I am having like a salt in water, on stirring I can see afterwards whatever the substance or whatever the solution I am getting, it's one single solution. I cannot pick out the, or I cannot select the salt crystals because it is dissolved completely, and that's why it is giving me a complete homogeneous mixture. Now here if I am talking about heterogeneous mixture, if I am pouring 2-3 drops of oil in water, do you think oil is going to get dissolved completely in the water? No, after stirring or after few seconds, we still able to see or differentiate between these two substances. I can see the oil particles above on the water, right? So that can be termed as what? Heterogeneous mixtures. So that was all about the chemical classification of matter. In our further course, we are going to learn about chemical classification in detail with some other good examples. As of now, that's how we are dealt with the introduction of chemical classification. Is it clear? Like, did you get any slight idea about chemical classification? All right. Moving ahead. So we have learned that matter is made up of particles. Now these particles are having different properties, and it's time to learn about the properties of particles of matter. First property is that matter is made up of particle. Yes, but how do we know about it? It's an activity time, let's see. So what I'm asking you all to do, even you can try it after the class at your home. What you have to do, take a water, okay, in a beaker or in transparent glass, and add some sugar crystals like 1 tablespoon, 2 tablespoon, and all you have to do is you are going to just stir it off. Okay. Now after the stirring, what you are going to observe? The level of water before adding sugar and the level of water after addition of sugar, is it going to remain the same or will it be different? Same, right? Why did this happen? Though we have added 2 tablespoons of sugar, because there were some spaces in water, okay, and now when you added 2 tablespoons of sugar, sugar particles get occupied or get accommodated in these spaces, and after stirring the complete dissolution happen, and that's why there is no change in the height of the water system. So this shows that there are some spaces between matter, and matter is consisted of small particles also. Okay, moving ahead. Particles of matter are very small. Let's see how. So here is the thing, like this activity is nothing but what we are going to take a chemical such as what? Potassium permanganate, okay, in 100 ml of water, and this is how the solution looks like, purplish in color, dark purple color. So what we are going to do, we are going to take 10 ml from this solution. Let me put it here, solution A. So 10 ml from A solution, then we are going to take beaker B, and then we are going to add 100 ml of water to it in the solution B. Again what we are going to do, from solution B, take 10 ml of solution B in beaker C, add 100 ml of water and see the solution. Again from beaker B, we are going to take 10 ml of solution out from beaker C, pour it in beaker D and 100 ml of water. That's how we are having A, B, C, D, 4 beakers of potassium permanganate and water. I just want you all to observe these 4 beakers. What do you observe? Beaker A is quite dark, right? If I want to compare it with beaker B, it's quite faded, right? And in between the color is getting fade out. So this is showing that no matter how many times you are adding water and making the solution diluted, but still it is showing some color because there is presence of small particles of matter potassium permanganate. And that's how we say particles of matter are very small, and that's how there is no complete color is not getting vanished, just getting fade away because it has small particles. Got it? Great. The next property is that particles of matter having space between them. The same activity, okay, here we are going to make second conclusion from the same activity, okay. So like after addition of this small sugar, how, like where these particles went? Actually there were some spaces and now they have accumulated themselves in those spaces, and after stirring we get a complete dissolution and the formation of sugar water solution, right? Okay, moving ahead, we are having next property, that is particles of matter move continuously. How? So have you tried this? Like take a glass of water, add 2 or 3 drops of ink. After some time or after some minutes, what do we see? The ink is getting distributed uniformly, right? Because when you are going to pour some ink or drops of ink, this particles of ink are going to get scattered in the water system, and after stirring or after some time they are going to get distributed all over the solution or water, okay. So that's how we can say they are having tendency to move here and there, and that's how the dissolution happens. And dissolution is nothing but intermixing of 2 or more substances, and that's how it happens because these particles have tendency to move. They are continuously moving from here and there, okay. So even it's not just about liquid, when we say gas molecule, they are also moving from here to here, okay. So random movement is happening from this place to that place to this, likewise randomly they are moving, and it is one of the properties of particles of matter. Got it? Is there any confusion? Is there any doubt? Okay. Now next is the property which we need to understand. Particles of matter attract each other. How? We are having activity for that. So we have taken 3 matter here or objects here. We are having iron nail, we are having chalk piece, okay. And if I am asking you like even yes, we have taken rubber band also. So if I am asking you to apply some pressure and try to break these objects or matter with the help of hammer, what do you think among these, like iron nail, piece of chalk, rubber band, which one will get easily broke down? Yes. So it's more easier to break down the chalk, then it's less easier to break the rubber band and difficult to break the iron nail. Why did this happen? It happened because the arrangement, if I want to draw, let's suppose this is a rubber, okay. So the arrangement of the particles which is there inside the rubber is quite tighter if I am comparing it with the arrangement of particles which is there in the piece of chalk, okay. And because of that piece of chalk, it can get easily broke down when I compare it with rubber band, and same is happening when we compare it with iron nail. These particles have tendency to stay together, they attract each other, okay. So yeah, that's all about the properties of matter, properties of particles of matter. Okay, so here is an again further activity, what you need to do is put unlit incense stick in a corner of your classroom, okay. Now I want to ask, are you able to feel the aroma or fragrance of it? No, right? But what if I am asking you to light the stick and now stand out your classroom? So are you able to feel the fragrance? You will be, right, because from one corner of your classroom the gas particles are getting moved, okay, and that's how they are reaching towards the corridor, and that's how you are able to smell them. Got it? So that shows that these particles are randomly moving, and the matter is consist of small particles also. Clear? Great. So here is the time to understand the physical classification of matter. Okay. So physical classification of matter is based on, I want to answer from you all. Keep typing in the chat box. I just want to see like how many of you all are able to recall. We have seen physical classification is based on what? Physical properties. Do you remember? Properties, like the properties which we are able to observe or measure. And it mainly talks about the states of matter, right? Yes. So matter, or it has what, 5 states. It exists in the 5 states, and they are solid, liquid, gaseous state. Then we are having 4th state, plasma, and followed by Bose-Einstein condensate. That is what BEC. Got it? So we are going to learn about them one by one. Are you all ready? Let's move ahead. So when we talk about like the physical state of matter depends on some parameters, what those parameters are or what are those factors. First is nothing but interparticle forces of attraction. Interparticle. So let's break the word. Inter, something which is between 2 atoms or molecules. Okay. So here we need to understand particle. Okay, so interparticle, distances between 2 particles. Okay, if I would have to draw, I'll show you it in this manner. It's particle 1, particle 2, 3, so on. Okay. There are some spaces, okay, and also these particles are going to feel force of attraction among them, and the rate, or I can say like how much they are connected to each other, that is depend on the spaces which they are experiencing. Okay. So more the space, less the force of attraction. Less the space, more is the force of attraction. Okay. This is what is the parameter number 1. Moving ahead. Here is the kinetic energy. It is nothing but energy the particular atom or particle gets out of the motion or the movement, right? Even this is responsible for that particular state of particle, of matter. Okay. So based on this, we are going to classify the matter in solid, gaseous, liquid, plasma and BEC. These are 5 states. So let's try to understand the very first state, that is what? Solid state. So interparticle forces of attraction are strong. Interparticle force of attraction, consider this is what is your solid is. Okay, and it is consist of what? Small particles. Okay, and the composition looks like this. So if it is consist of small particles like this, interparticle force of attraction are strong. Just now I told you, if the spaces among these particles are very low, that means they are experiencing the force of attraction which is very high. Okay. So less space, more force of attraction, and where we got to see it, we got to see it in solid state. Okay. Particles are not free to move but they vibrate. Now here as I drawn the arrangement of these particles, do you really think that are they able to move from the place to other? No, right? They are very compact, but they can vibrate on the position where they are. Okay, so wherever they are locating, they can vibrate on the position where they are already. Okay, so these are some properties of solid states. Now next is less interstitial spaces between the particles, and that's what we talked about. Interstitial spaces, that means the space which is there in between two particles. We know that the arrangement of particles is such a compact that particles can't even move. Okay, the space is that low or that less, and that's how they experience the strongest force of attraction if I want to compare with liquid or gas particles. Followed? And that's the reason we say solids are rigid, they are compact. This remote is solid, this pen is solid. These are few examples of solids. And it depends on the internal arrangement of particles. Followed? Okay. So here is the one activity. This is a pen, okay, a pencil. We are having a table and a needle. So these are 4 different objects which are examples of solids. But can you observe this shape of these 4 objects? Are they like exactly the same? No, right? So pen has cylindrical shape, a little bit similar to like pencil, but not exactly the way pen is. Then table has its own shape, needle looks very different, right? So basically they are having their own shape, okay, and they are occupying their own volume. So is it ringing a bell to to understand the property of solid object? Yes, right? So let's understand. So solid particles or solid objects are having their definite shape and volume. Got it? Now density. As we have seen, the arrangement of particle is in such a manner that particles are they are staying together. There are no space, no interstitial space. So the whole arrangement of matter is quite dense. Okay, and we are having high rate of density in solid. Now compressibility, ability to compress. Do you really think that are we able to compress the solid particle very easily? Is it possible? Compressibility is nothing but ability to press down the substance. Now such a rigid or compact structure, will it be easy to compress it? No, right? So they are not highly compressible. We can't compress solids. Next, rigidity. Okay, they are very tough, they are very hard, they are very rigid because of the internal arrangement of particles. High mechanical strength. Now what do you mean by mechanical strength? It's a strength or its ability to bear, or we can say bear some pressure or load, to withstand some pressure, load. Okay, so high mechanical strength is experienced by these particles. They have this strength, they can bear the pressure or the load or the burden. Okay, then we are having the next property such as diffusion. Diffusion is nothing but ability to intermix with each other. Solid particles generally do not show diffusion. They being solid or rigid, they do not have tendency to get intermixed with each other. Okay, so rate of diffusion is quite low when we talk about solid particles. Then melting and boiling point of solid particles. What do you think? By studying all these properties, I just want a single comment from you all. What do you think, what will be the trend in melting point and boiling point? Will they high or will it be very low? That's correct. The structure if you see, it's quite rigid, and now if I want to break these bonds, I will have to supply more amount of external energy, and that's how we can say melting point or boiling point must be high when we talk about particles of solid. Agreed? Great. Here is the very important property. It says or talks about crystalline geometrical structure. Okay, So now these particles are arranged in themselves in such a way that they tend to form a particular shape. Okay, so regular arrangement of particles giving the solid structure, a rigid structure, a specific structure. Like if I want to give an example, okay, something like this, okay, crystal, if I want to draw a crystal. So how this crystal has got this shape? Because the regular or proper arrangement of the solid particles. And generally we tend to see the crystalline structure or fixed geometry in case of solid particles. Alright. Again, very important property, sublimation. Okay, we see like there is transition is happening from solid state to liquid state to gaseous state. Okay, that's a regular trend of transition of one state to another. But in case of solid, they have this tendency like solid can directly get transformed into gaseous state. Okay, there are some solid substances which are going to show this sublimation property, like from solid they are going to get directly shifted into gaseous state. Okay, so ammonium chloride, naphthalene, these are some examples of sublimation phenomena, okay, which is getting observed in solid state only. Okay. Yeah. So students, that's how we are like towards the end of this session, and it's time to sum up whatever we have learned so far. So let's go through it quickly. So we have seen definition of matter. Matter is anything which has its own mass, volume and can be perceived by our senses, right? Then what is the composition of matter? Matter is consist of what? Yes, particles, right? So it has a particulate nature. Great. Then classification of matter. I want answers from you all. Okay, type like what are those classification which we have studied? Physical classification and chemical classification, right? Great. Then characteristics for particles. Okay, matter is consist of small particles. These particles are having what they are experiencing force of attraction. They are moving from here and there. So randomly they are in the continuous motion. Okay, and also these particles are having spaces. Physical classification of matter. Into this we have covered all the properties of solids, right? So it's time to solve some questions based on which whatever the content which we have covered. Let's solve some questions. Which of the following is not an example of matter? Lunchbox, table, chair, expressions. What do you all have to say on this? Among these four options, which is not an example? Emphasize on the word not an example. Keep typing in your chat box so that I will understand like how many of you are getting it. Okay. So it's time to reveal the answer. Yes, the correct answer is option D. Be it lunchbox, table, chair, these are all examples of matter because they are having their own mass, they are having their own volume, we can perceive them through our senses. But what about the expressions? We cannot measure them, they cannot occupy some space, and that's how they are not an example of matter. Alright. Now we are having next question such as which of the following shows the property of sublimation? A solid which can get sublime: water, sodium chloride, ammonium chloride, sugar. So we know that sublimation is the property which is shown by solid particles. So definitely you are going to eliminate option A because it's in liquid, right? So your answer lies among B, C, D. Like, what do you all have to say? Correct. So correct answer is what? Your answer or option number C. Okay. So ammonium chloride is the right answer. Just now we have seen an example like chemicals such as ammonium chloride, it gets sublime or it's transformed like solid state from solid state to gaseous state. Okay, so this is the big question. So pay attention. Statement 1 says that interparticle force of attractions are strong in case of what? Solid particles. So force of attractions are quite stronger. Statement 2 said that solid particles have more interstitial spaces among them. Okay. So now you are supposed to comment on this, like whether A is true, B or C or D. Which one is the correct? Think over it. I am giving you few seconds. Interparticle force of attraction are strong. Keep typing. Okay, I can see many of you are getting it right. Cool. So this is the right answer, like option D. Only statement 1 is correct. Statement 1 is interparticle force of attractions are strong in case of solid particles, which is right. But statement 2 says that solid particles have more interstitial spaces among them. Do you feel so? That's what we studied. No, right? So statement 1 is absolutely correct, but statement 2 is incorrect, and that's how we are not interested in ABC, because we got our answer. D is the correct one. Okay. So that was all about today's session, students. So the rest concepts we are going to get covered in the next session. Till then, bye, take care, see you next time.